Great. Okay, so I'm going to talk about cross-plane testing patterns, and my colleague Yury is going to talk about end-to-end testing. So in mine, we're actually going to follow up with some of the concepts that Philippe showed there. Basically, with functions, there's a lot we could do in the command line to mock out testing, and just I'm going to walk through some of the things that we do with our customers to help them develop things interactively. So there's a repo here that I have some of these examples at. It's Stephen D. Borrelli composition testing. And the goals is that one, as you can see, before functions, a lot of times we had to like apply things, manifest to the cluster and see what would come out of it. With functions and some of the new tooling that we have, you could render things right on the command line immediately. And you could catch errors faster too. We could do things like validate compositions, and obviously you're putting out the YAML, so you could see what's changed between different versions of your composition. So that's really the goal of this, is moving development closer to the developer and closing the loop on adding new features. So you kind of saw a sample of that at the last slides. Starting with 114, we added the Crossplane CLI that can actually render compositions and simulate what would happen in the pipeline. And what's happening there is the command is Crossplane beta render, and when it graduates, we'll remove the beta, but right now it's still in a beta status. And there's 3 files that usually provide to it. You provide the XR, right? So that's what the customer is going to ask for. The composition, and then functions. We need the functions because the way Crossplane beta render works is it has a local Docker run, and it basically downloads these functions and then executes them step by step in Docker containers. And the end state of this is that it spits out your rendered YAML, which is what you would use to see if what's getting generated is what you want. So this is the basic, and you need a minimum of Crossplane CLI 114, and 115 added a few more features, but really, so we just already did this one. So let me just do a simple demo of that, and then we'll talk about mapping resources. So I'm going to share my screen here. So again, this is similar to before. We have an XR for an X tenant. And in this case, what we want to do is we're using function go templating, and you can see here. And what we're going to do is we're going to range through the teams that we have. So let's say that you're onboarding tenants and you want to create namespaces for them for each tenant. So they could ask for what they want to have generated here. And so what we're going to do is we're just going to loop through that. And then at the end of it, we're going to populate the UIDs of those namespaces, right? And then set the status. So if we render this basically, we're going to get our results here. You could see we're going to create, we're creating our resources, but you can see here the resources, we're speccing them out. It says that they're not available. You can see here for the namespaces, the UIDs, we're not getting any values back. But we really don't know if this code is working where we're actually getting the status and publishing it back, right? Because we don't have any namespaces right now created. So what we want to do is we want to actually mock external resources. And let's talk about that, the data types that we could do to do that. So there's several different types of data types that are in compositions. The first one is environment configs, and you could think of this as like a glorified config map, right? It's similar to a CRD, and whereas a config map has like a key value, this can have any kind of data structure in it. It could have nested maps and arrays and things like that. Environment configs are still an alpha feature in Crossplane, so just keep that in mind that they could be deprecated at any time, but they're pretty heavily used in the community. The next thing is observed data, right? So when you run a function, Crossplane sends to the function the set of all observed data. So that observed data includes the XR that the user asked for, and then if any resources exist, that array of resources is going to come in with all their statuses, right? And then the third thing is something that was new in 115, which is really promising. It's extra resources, right? So what this is that Crossplane can select now on behalf of the function, basically any other Crossplane object on the cluster, right? So you can pull in things like environment configs or other compositions and bring them in to your function here, and then use them, have your function operate on them. So you could imagine you can have like one composition that maybe queries and has your standard set of like VPCs across the organization. And then your extra resources on all your sub functions could come and query for that and pull it in and like use the VPC ID in the region. So in Crossplane beta render, to use these, we have several command line options, right? So if you want to use extra resources, you're going to use the extra resources command line. And we'll have an example of this in a bit. Observed data, there's observed. And then finally, environment configs. We use something called context, right? So this is directly populating the context with JSON. So what happens there is you actually put like a JSON map and it'll be added to the context. All of this gets added to the context of the function. And then in the composition pipeline it runs. So things like extra resources, Crossplane provides it to the composition, but the functions don't necessarily know how to use it unless they're programmed to use it. So we'll talk about the functions that are available to use that. All right. So what we're going to show here is, and then we'll go through the example here. So if we wanted to use all these different features, here's some of the examples here. So extra resources, we point to a directory, and this is a directory of YAML files. Observed resources, again, are a directory of YAML files that represent observed resources. And this one is interesting that basically, this is slightly different when using context. And in this case, we're using a file. We're setting a key at a well-known environment. So you're going to see this like API extensions, crossplane.io. So when you're writing your functions, this is actually where the data is going to be for the context. And in this case, we're providing it with a JSON file. And finally, the other options we have include full XR. This includes the spec, and then we're going to push out the context. So if I go here to my example, we'll make this bigger. We're going into mocking data here, and we can take a look at this, right? So if we look at what the dev JSON looks like, it's just going to be a raw JSON file. And this will be brought in under that API key. If you look at extra resources, what you're going to see here is we have two environment configs, right? We have web dev with like things like an account ID and a role, and then we have one for prod, right? And you can see here that we have selectors on each one of these environment configs. So we'll be using this with our function later on. And then finally, we have a couple of cross-plane resources. You can just pull these in if these are other compositions. Under observed, this is where we actually mock other data. And what you could do to generate these is you could just do like kubectl get existing objects. And you could see here that this has a composition resource name. So this will match what's in your composition, right? So we're creating namespace team2. If you look at your composition, when we create the resource in our composition, it's going to match this object in the composition. So keep that in mind. So this is how you mock objects. This is how you get external objects that are mocked to run in your beta to match up. And you can see here, this is just a raw dump of Kubernetes. We're going to have a spec. And the most important thing is the status, right? We're going to use the status to bring in data. So if we look at our new composition here, the one that's using the mock data, let's talk about what's happening here. The first step in the pipeline is we're going to get extra resources, and we're going to pull in those environment configs, right? So what we're doing here is we're putting it into something called env confs, and we could say how many we want to match, either like, one or how many max you can match in here. And what I'm doing here is I'm matching what the user puts in a group and environment, right? Like, so we're going to say what group is this customer coming from and what environment, and then we're going to match the environment config to that. So let's get an example of what they're asking for. So if we have an XR here, the customer is like the web dev group and their environment is dev, right? So this is going to be mapped into our composition. Okay. We'll use this composition. All right. We talked about those well-known keys. This is it here, right? we're putting it in here, and what we're doing is we're getting the end comps, and we're getting the first one that's brought up, right? So in our extra resources up here that we're pulling in extra resources, we're putting it into a variable called env comps. So when we go down here, we're going to say, let's pull the first environment config out because we only want to match one. And then we're going to get labels out of that, right? So when we come down here, we're going to range through, and now we're going to just add the labels to each one. So yeah, let's try generating this now. So again, we're pulling in the observed resources, the extra, and let's just render this and let's see what comes out. Okay, let's make this a little prettier. Okay. The first thing we want to show, now that we're mocking data, what you could see here is you could see that the conditions are ready now, and that because we've had those UIDs for each one of the namespaces or status, if you go down here and you look at the labels for each object, you could see now that we're pulling in the business unit and the labels for that environment config, right? So each object now is getting the labels that are coming in from the environment config because we're selecting it based on the XR status, right? So we have our 3 objects here. And then finally, you can see here the context, we're just dumping this in. And you can see how things are a little different here, right? So I wanted to point this out, and we have a slide about this, but it comes in, and this is a map of that JSON file that we showed. And then when we look at extra resources that comes in, you'll notice it's an array, right? So like we pull things into X cluster and env comps. And you can see here we get an array of data, right? So in this case, we're only selecting one, but we could have multiple objects get pulled in, and you need to match properly on the key. You know, usually in this case, it's a metadata name you may want to match on, or you may want to match on labels here too of the object that comes in. So what we've just demonstrated is pulling in external data, matching external data, you know, using environment configs and matching things using selectors, right, that are based on what the user asks for. And then finally, mocking in the data when we call our render.shell. You could see here, we pulled in our observed resources, we're saying our extra resources, and then that JSON file we're pulling in into our context. So you can see how all those things become present when we're rendering our manifests. So this is a good way of simulating real clusters, what would happen when you actually have real resources that are getting provisioned. All right, I've got, let's do 1-2 more slides and then I'll move on to the next person. Okay, it's basically, again, just this is reiterating what I said before, is that the different ways in which the context of the function gets populated. This is environment config, this comes from function environment configs, or the context via the CLI, and then this is the extra resources that is populating this. Finally, the last thing I want to show is validating. So this is a new option that came along with render, and we could basically validate against an existing schema resources, right? So in this case, what we're going to do is we need to include the full XR because we want to include the spec, and then we're going to validate here. Like this is the main command here. In this case, I'm just mocking CRDs that are in a directory, but you could also point this at like a configuration package and it'll download the configurations. So let's just show a quick example of this, and then I'll hand it off to my partner. All right, so all right. What we're going to do here is, if you look at the command, we're basically rendering. In this case, I'm not including the context because there's no CRD for it. We just pipe that to Crossplane beta validate, and you'll see here I'm just including the local directory because I have the files and the CRDs in this directory, and I'm just piping the standard output from the rendered resources up here. And what you're going to see Crossplane validate do is it's going to go through, it's going to first validate the XR, And then it's going to go through, and in this case, we're creating Kubernetes objects, so it's going to go validate those. And if there's any issues, you can go see it here. So this is the other thing, like you can have some folks use like a local package mirror and they push to a package or configuration package and they test it that way. So this is a way you can validate your compositions in a pipeline and make sure that what you're actually generating is creating valid CRDs. And with that, I think I'm going to pass it over for end-to-end testing to Yury. Let me just stop presenting here.
All right. Hello, everybody. I'm sharing my screen. So hopefully my slide is visible. I'm Yury. Thanks a lot for joining today. Let's chat about end-to-end testing. So first thing first, you just seen an amazing presentation by Steven and Philip, and they were demonstrating capabilities of local rendering, right, and local validation. So you already have a pretty good level of development experience in Crossplane. You can locally render, evaluate. It's a very fast feedback loop, and it is great, right? It's fun to work with. You are enjoying building your compositions now. But still, at the end of the day, you need some form of real acceptance test. You need to instantiate your claims, your composite resources, and see how cloud resources and your Crossplane configuration are actually working in a real-life scenario, right? And so usual approach for this kind of end-to-end test flow, a very development style first. After you done with all local rendering, everything was good, you're going to apply your configuration, effectively composition and XRD to some local testing cluster, right? Then you're going to apply the stuff under test, a claim or composite resource, and then you evaluate behavior manually. So that's pretty fine for a manual kind of exploratory test cycle during the dev, but eventually you need some form of consistent end-to-end testing that would automate these evaluation steps for a real-life end-to-end acceptance test. And even more ideally, you would like to have a naturally growing regression test suite. So some form of automation that would test your examples, your configuration, especially for regressions. And during the changes, you will have a full confidence that nothing is getting broken. So with that in mind, I would like to introduce Uptest, our end-to-end test frameworks that is focused on testing cross-plane providers and cross-plane configurations. And I like to reason about Uptest is like low-code end-to-end test framework, meaning that you almost, when everything is set up, you need no to write any test code. That is amazing. That's not much the main thing, right? You just need examples for your repository that you anyway need for like kind of formal documentation. So claim, XRs, MR examples in your associated repo, and you're good to go. Test will run the full end-to-end test automation for you. And a little bit of history. It was created by Upbound to support three main official providers, right? So as you can imagine, AWS, Azure, GCP is a serious exposure, a lot of MRs, and to support the velocity and reliability and quality of the providers, we created Uptest to actually back us up, right? So during the development of official providers. And eventually, we reuse the same approach for the configuration. So you can use Uptest for any configuration you like, a custom one. We are using it in our reference platforms and all the additional configurations that we are maintaining publicly and for our customers. So Uptest helps us a lot. And last but not least, we recently contributed it to CNCF. So currently it lives independently in a Crossplane repository without any vendor branding, so available for everybody. It was always open source, but now we just, highlighting that Uptest can be used in vendor neutral scenario. So a little bit of capabilities. So basically, Uptest can execute a full CRUD style for you for your manifest under test. And you can test all the cross-plane layers, right? From underline MR if you're testing the provider to XR and claim if you're testing cross-plane configuration. And yeah, usually no special test code needed. You just need an example YAML file in your repository. And how it works like this semi-automatically is that it generates a cattle test suite in background for you, and you don't maintain these cattle tests at all. All the assertions are predefined by uptest, and it catches like 90% of what you need when you're working with the cross-plane provider testing and configurations. So usually we have a configuration or provider repo and a set of examples that are anyway there, and assuming uptest is integrated in the repository, these examples will be automatically tested for you. So a little bit of specific steps of uptest. So as I mentioned, it automatically generates a cattle test suite for the crossplane manifest under test, so claim, XR, or MR, and basically all the steps are pretty much transparent. So you can go to the uptest repository and understand what it does for you, but usually you are not touching this layer at all. You just executing it, and uptest will run all the steps for you. So uptest, it's important that uptest will build the provider or configuration package locally and upload it to the test cluster, so it will create as this level 0, step 0 setup first, and then it executes a CRUD-like flow for your example manifest. So it applies, checks if everything is fine with assertion. If you have a special annotation, and yeah, that's a thing of uptest, so it's kind of low code, and you drive the special cases with annotations on a resource under test. So this is a real life example in our provider AWS repo, and with that special annotation of uptest that does nothing in a real crossplane scenario, but it drives a test to update the specific API field during this test run. It will create this update flow, and then with a post-update assertion, it also verifies that everything is fine. Then it does another important for crossplane work operations, the import. So basically kind of deletion orphan, and then import everything massively with external names and checks that everything is fine in that import stage. And then last but not least, the deletion is super important. Sometimes in our configuration, we can hit some specific edge cases. It also validates that everything can be deleted in a clean manner, and it also leaves no leftovers after your test cycle. For end-to-end testing, it's a very important step. So on top of this powerful CRUD-like flow, we also have additional things like hooks and helper functions. So you can hook into every step in the life cycle and basically inject some custom logic. It can be very useful in a provider level testing, in configuration level testing. Now we rarely use it because standard use case for that was the deletion ordering. Now we have usages, as Philippe mentioned, and usually we don't need to create some special hooks in a configuration level testing. But anyway, this capability is pretty useful. And in addition to that, we have helper functions where we can inject in our pipeline some special sensitive values to the manifest and randomize the metadata name. It's a simple function to generate RFC 1123 compatible names. And this way, you basically you template your example manifest and you avoid the clashes during the parallel test run. So pretty handy. This is for a core uptest capabilities. You can also integrate the uptest easily into your pipeline. So everything basically dropped in a make target and set of make targets. And also we are providing reusable GitHub action workflow where you can just easily plug into your GitHub repository. So workflow itself is pretty heavy one, but you need to copy it. You just can reuse it in your in any repository that you would like. So that you can just reuse PR command trigger and plug it in. So it's also very useful, and it provides a capability for a centralized run, right? So I can run test examples and invoke uptest for my configuration in automated way, in centralized manner. And we also, depending on configuration style, for large repos like providers, we also have a capability to point to the specific example under test. For simple configurations, we just test them all from example directory. So pretty straightforward. All right, super quick demo. We are going to use configuration in AWS Network. It's just one of the reference platforms that we maintain in Upbound, that's available publicly, and you can use them anytime. So we have this examples directory with things under test. And in this case, it's going to be just a composite resource X network, and we're going to execute a test flow, end-to-end test flow for our code, the composition and the definition, and it's going to be locally packaged according to Crossplane YAML configuration. So I'm here in this repo, and what we need to also look at, we have a make file. I mentioned this centralized set of make targets, and that's basically a wrapper for uptest. And what we need to for successful uptest run, we need to propagate the credentials, and that's pretty much it. The similar style, as you can imagine, we can do in the pipelines, and then we can just make an E2E target. So what it's going to do? First thing first, it builds this configuration locally, right? So you can test any code that you're working currently locally at without pushing to some OCI repository. So pretty fast feedback loop for end-to-end test. It spin ups a fresh testing cluster, so it's from scratch. It's a clean cluster, so to provide you with the environment with enough isolation, and it will be just only your configuration and set of configuration that is going to be deployed there. This is the trick with the dev sidecar, so that's how your testing configuration is getting propagated into test cluster, into Crossplane, make it right away directly without the round trip to the OCI repository like marketplace. So it's pretty efficient. And now after the configuration and providers are ready, so first it checks for the configuration to be healthy and installed. So in parallel tab, we can already interact with our test cluster and check configurations. So it's still in an installation phase, and uptest will wait for its readiness. Then it proceeds to the associated provider check. So every provider involves provider that are getting installed as a dependency after configuration. We are going to wait that they in healthy state. And then after providers are ready, we are proceeding with this CRUD-like test flow, right? So applying all the manifest, we already should have the example manifest applied. So these X networks that we showed before. So let's check it out. The composite is around, right? And we can use a cross-plane beta trace for X network and this AWS network example. So everything is going to be is in a process of being provisioned, and you don't need to look at it. Uptest will automatically take care of everything, checks the readiness state, checks that it can be imported afterwards, and you may perform a clean deletion, right? So this is end-to-end test runs that can be executed in background. And on top of that, as I mentioned, the GitHub repository integration. So that's how pull request level integration looks like. So I already made some comments early yesterday, actually. So test examples. It provides a feedback, uptest feedback right in the PR. And if you're interested in more details, what is happening there, we can go there and check exactly the similar test runs that we just executed locally. So we have this dev test parity. And if something is unclear, we can go and grab the control plane dump. So we have pipeline is generating a full archive where we have all the necessary things for debugging. All the log dumps are available for in case something goes wrong. Yeah, so that is for the current state and the demo. So as you can see, you can use it locally, you can use it in your pipelines, and it's pretty powerful. So what's coming next for uptest? As we discussed, we are using Cuttle underneath to generate this automated test suite. And we have a plan, an approved one-pager that we are going to switch to Chainsaw from Caverna. That is kind of successor to Cuttle. It provides much more powerful assertions capabilities, assertions trees, better logging, and we also don't lose current test suites because we will have a full backward compatibility with the Cuttle test and just the examples that we maintain in our repository. So no breaking changes. And if you're interested in Chainsaw, check out Victor's video on his channel. As you know, Victor has amazing videos for almost anything that is happening in community. So Chainsaw has a great coverage of a Chainsaw as a tool, so can highly recommend it. And yeah, just to conclude the session, try uptest. To try uptest, you can just clone arbitrary configuration. Configuration at the Borrelli network is just one simple example. You can investigate, make targets similar to what I showed in the demo, configure cloud credentials. Don't forget to make some models to pull in our amazing build models that will enable a lot of heavy lifting for the CI pipelines, and run, make, and tweak. So basically, after you get this test flow on our repository, it's very easy to integrate with your custom one and transfer this end-to-end mechanism and uptest into your custom repo, provider, or configuration. So yeah, that's pretty much it. I hope I managed to share the usefulness of uptest. Try it out. It can bring your end-to-end testing pipeline and regression testing to the next level. And leave us feedback at the repository. And obviously hit me up in Slack or LinkedIn whenever. I'm happy to answer any questions.